All right, so we are taking a look at day number 3, and we are going to be talking about the cool down called, what is it? A growing puppy. So, a few key concepts before we get to the cool down. First of all, relationship between two quantities is a function if there's exactly one output for each input. We call the input the independent variable and the output the dependent variable. I've said this many times. You need to know this. It is not a function if there are multiple outputs for the same input. So this right here is how we write functions. We read this as f of x. So f of x. F is the name of the function. My input is the x value. That's what's going into my function. And then f of x is what my function does to x and gives me an output. So the way I've thought of this and the way I've described this before is we can think of a function as being like a machine in a factory. This is going to be a really dumb illustration. It's like a machine in a factory. This is my function machine. What we do with our function machine is we take x values and we put them in. These are our inputs. And then on the other end, our function changes those into y values, outputs. Oh, I ran out of room. Anyway, x inputs, our function takes it and changes it into a y output. It's like a machine in a factory. So let's take a look at this, how this works. So here are two graphs of functions, each representing the cost of riding in a taxi from two companies, Friendly Rides and Great Cabs. For each taxi, the cost of a ride is a function of the distance traveled. The input is distance in miles, and the output is cost in dollars. So input, distance, cost in dollars. They're both functions. The point 2, 5.70 on one graph, that's this point right here, tells us the cost of riding a Friendly Rides taxi for 2 miles. So when we go 2 miles, we see that our cost is $5.70. The point 4.25, this one right here, tells us that the cost of riding a Great Cabs taxi for 2 miles. So the dashed line is Great Cabs. The red line is the Friendly Rides. Now, if we name the Friendly Rides graph function f and the Great Cabs, which was the dashed line, function g, to refer to the cost of riding each taxi for 2 miles, we can write, well, for Friendly Cabs, the cost for riding 2 miles would be f of 2. So f of 2 is the cost for 2 miles in Friendly Cabs. 2 miles in Great Cabs, Friendly Rides. The cost for 2 miles in Great Cabs is g of 2. Now, f of 2 is in fact 570 and g of 2 is 425, but we don't necessarily have to write the 570. We can just say f of 2, and that's the cost of Friendly Rides for 2 miles. G of 2 is the cost of Great Cabs for 2 miles. So looking at this, to say that a 2-mile trip with Friendly Rides will cost $5.70, we can write f of 2 is 570. For a 2-mile trip with Great Cabs, we could say that g of 2 is 425. So let's take a look at this. Function q gives a puppy's weight in pounds as a function of its age in months. So if we're thinking about q of number of months, we're putting months in to our function, and then q of m is going to be the weight of a puppy after m months. So for example, if I say q of 2, that's the weight of the puppy after 2 months. So what does each expression or equation represent in this situation? What is q of 18? What is q of 30 equals 27.5 telling you? Then use function notation to represent each statement. When the puppy turned 12 months old, it weighed 19.6 pounds. Or when the puppy was a month old, it weighed w pounds. If you have any questions about this, let me know.